Hello guys, this is Jefferson F. Willin, BSc student at Don Mariano Marcos State University, Midla Union Campus. I made this video because our instructor required it to be documented through and be posted in YouTube. This video consists of report in daylighting design and analysis, and I am the one who will doing the reporting and reading. So, daylighting design and analysis. Daylighting design and analysis. In this topic, we consider the daylighting designs in buildings and other structures, and how we can analyze it and the benefits and of these designs, daylighting designs. Lighting. There are three basic purposes to be considered in lighting within indoor environment. First, the basic purpose is to enable the occupant to work and to move about in safety. With proper lighting, we can move freely and through, we can move freely and safely in that building because the lighting is just okay for sample doing works and other activities. And the second basic purpose is to able to enable tasks to be performed, and the third is to make the interior look pleasant. There are two principal ways in which building can be lit. There are the natural, the sunlight, or the daylight we receive in the sky, and the artificial, the electric lamps, and other artificial light sources that is being used in today. In daylighting, there are two distinct sources of light. One is the sunlight, and second is the skylight. Sunlight is the part of solar radiation which reach the Earth's surface as a parallel ray rays after selective attenuation of by the atmosphere. While the skylight is that part of a solar radiation that reaches the Earth's surface as a result scattering in the atmosphere. Daylighting. Daylighting is the controlled admission of natural light into a space through window to reduce or eliminate electric lighting, to provide direct link to the dynamic and virtually involving patterns of outdoor illumination. Daylighting helps create visually stimulating production of environment for building and occupants, while reducing as much one-third of total building energy costs. Benefits of daylighting. Daylighting has a potential to significantly improve life cycle costs, increase user productivity, reduce emission, and reduce operating costs. Benefits of daylighting. One is the improved life cycle cost. Life cycle cost is the estimated incrementation first cost increase from 50% to 0.75%, 75 cent per square foot of occupied space for dimmable ballast, fixtures, and controls. Daylighting can be shown to save from 5 cents to 20 cents per square feet annually. Increase user productivity. Daylighting in live space and have been shown to increase user satisfaction and visual comfort, leading to improve of performance. Reduce emission. By reducing the need of electrical consumption for buildings, lighting and cooling, the use of daylighting reduces greenhouse gases and slow fossil fuel depletions. Reduce operating costs. Electrical lighting accounts to 35 to 50% of total electrical energy consumption in commercial buildings. By generating waste heat, lighting also add to load of imposed on the building mechanical cooling system. And energy saving from reducing electrical lighting through the use of daylight strategies can directly reduce building cooling energy usage to additional 10 to 20%. In reducing operating costs, for example, uh, in a commercial building, they uses they uses air conditioning. They use aircon for their cooling system. And like for example, they use also lamps and other lights or electrical light sources. By uh, designing or using daylighting designs and schemes, they can reduce the operating cost of the cooling system because uh, the building uses less lamps that produces heat and radiation that can cause to the longer time for the cooling system to operate. Daylighting concepts. Daylighting concept it is important to appreciate the daylighting designs. Process involves integration of many disciplines, including architectural, mechanical, and electrical, and specially lighting. Uh, First, the awareness of basic visual acuity and performance visual is essential to effective daylighting designs. Veiling reflections. Veiling reflection is a high brightness light source of specular shine surface obscure detail by reducing contrast that should be avoided, particularly where critical visual tasks occur. Distribution. Introduce as much control design as deep as possible into the building interior. The human eye can adjust to high level of illuminance as long as it is evenly distributed. In general, light with rich touch of eye indirectly will provide better light quality than the light arrives directly from natural or artificial light. Glare. The aim of efficient daylighting design is not to only provide illuminance levels sufficient for good visual performance, but also maintains comfortable, pleasing atmosphere. atmosphere. Glare or excessive brightness contrast within the field of view is a speck of lighting that can cause discomfort to occupants. The human eye can function quite well over a wide range of luminous environment, but does not function well in extreme level of brightness as a present at the same field of view. Yung glare is can cause accidents. For example, uh, when you are driving in a dark place, you usually use daylighting. Daylighting. You usually use high beam lamps that is mounted in front of the car. When you are traveling and design elements for daylighting designs. Exterior element. Overhangs can be useful controls for fenestration in addition to blocking the direct beam from sunlight. They will also reduce the amount of sky seen from within the room, thus reducing the amount of diffuse reflected light from the ground or other surface can be also caught by overhang and directed back into the interior of the room. The result will be a slightly higher luminance level and more even distribution of light in the space. Light shelves are typically horizontal devices that located near the window area. Successful fenestration systems have integrated both interior and exterior light shelves. They are used primarily to reduce window brightness by blocking the direct beam sunlight from entering the conditional space. Lit shelves also have a potential to increase room brightness by reflecting light into the building as a design element. Light shelves can often introduce a strong horizontality to the building facade. Daylight tracking and reflecting system are designed to enhance the daylighting and potential daylighting potential of skylight by tracking and reflecting sunlight through an aperture and into an open space below. This type of equipment can be either dynamically controlled to follow the path of the sun or completely stationary using strategically placed mirror to capture the direct beam daylight. Because low angle daylight can be better utilized and used for this equipment is able to extend the hours within a day as well as months within a year. The natural light can be effectively replaced or complement electrical lighting. In-wall and roof in-wall and roof elements. Glazing materials. The simplest method to maximize the amount of available light within a building was the increase of total amount of glazing present in the building envelope. In May, in many cooling dominated climates, admitting more light has until recently meant admitting unwanted heat gain as well. So if you admitted more lights in the building, you can that you will be admitting more heat to that building. So cooling system or the cooling capacity of that equipment can be increased so that it will compensate with the additional heat is entering that area. Interior elements. You must always consider the room geometry. The depth that the daylight will penetrate is dependent on the ceiling height retrieved relative to the top of the window. A window height will allow entering daylight to strike the ceiling plane and reflected into the interior of the space. Reflectance of the roof surface. The reflectance values of roof surface will greatly impact the preference of daily space. The ceiling is the most important surface in the reflecting daylight coming into the space onto the work plane. And the next most important surface is the back wall, followed by the side wall, and finally the door. The designer keep the ceiling as light as possible and use only floor for pattern or deep color. Dark color on the floor will have the least impact in the delete space. Option in daylighting designs. There are options in daylighting designs. First, the side lighting. Side lighting concept use the wall of a building as a location of aperture to admit daylight. The aperture can also be served by incorporating view and ventilation as design dynamic. Side lighting provides illumination with strong directional due to the diminishing light level as the distance from the aperture increases. This, the second option in daylighting design is top lighting. Top lighting concept allows the daylight to penetrate space from aperture that are located above the ceiling light and usually constitute part of roof of the building. And all top lighting concept provides interior lighting within distribution, pattern, and character significantly different from those provided by the side lighting. Lighting effects can vary dramatically depending on the configuration and placement of the roof aperture. Not only can consistent and relatively uniform daylight distribution be accomplished by dramatically high intensity by introducing strategic area as well. And the third and the third is the core daylighting design. Core, core daylighting refers to strategy that implementing optical system to the light space of the building with sunlight that may receive both electric lighting and cooling loads. Three elements to core daylighting system. Collection system, capture daylight and redirect it. And it may be located in the interior of the building, on the roof, or on the exterior walls. Two types. Active optical system, using tracking system that follows the sun and its move across the sky and re-erect the direct beam solar into the interior of the building. Passive and passive optical system implement fixed element to view the most favorable and brightest portion of the sky dome and direct the light into the light transportation system. In this collecting system, they use as, for example, reflectors. Reflectors, they reflect lights. Three elements to core daylighting system. The first is the collection system, second the light transportation system, and last the light distribution system. Light transportation system, the core daylighting system moves the collected daylight from the collection system to the light distribution system where light is required meant exists. New materials have been developed to overcome some of the limitations associated with transporting light any significant distance. The most common type of transportation system is either fiber optics or light duct lines with highly reflective materials. Reflective materials. Third is the light distribution system. Receive a light input from a transportation system and distribution light into target area or space. This element of system then carries a light from the transportation system and emit light within the building. Design recommendation in daylighting. A normal of daylight strategy should be understood and explored during the design process. These strategies are briefly described below. Describe. Increase perimeter daylight zone. Extend the perimeter footprint to maximize the usable daylighting area. Allow daylighting penetration high in space. Window locate the high in wall or in roof monitors. The claritories will result to deeper lighting penetration and reduce likelihood excessive brightness. Reflect the light within a space to increase room brightness. A light shelf is properly designed has the potential to increase room brightness and decrease window brightness. Slope ceiling to direct more light into the space. Sloping the ceiling away from the penetration area will help increase the surface brightness of the ceiling into the space. Avoid direct beam daylighting on critical visual tasks. Filter daylight. Understand the different building and orientation that will benefit the different daylighting strategies. For example, light shelves which effective on south facade are often ineffective in west and east elevation of the building. Materials and methods of construction of daylight design or schemes. Exterior shading and control devices. A hot climate exterior shading device often work well to both reduce heat gain and diffuse natural light before entering the workspace. Example of such device include the light shelves, overhangs, horizontal louvers, vertical louvers, and dynamic tracking for reflecting system. Glazing materials. Glazing materials, the simplest method to maximize daylight within a space is to increase the glazing area. However, these glass characteristics need to understood in order to optimize the penetration system, U value shading coefficient and visible transmittance. U value represent the rate of heat transfer due to the temperature difference through particular glazing materials. Shading coefficient is ratio of solar heat gain of a given glazing assembly compared to double strength single glazing. Visible transmittance is a measure of how much visible light is transmitted through given glazing materials. Third, aperture location. Simple side lighting strategies allow daylight to enter a space and can be also served to view and facilitate view and ventilate. A rule a rule of thumb that is depth daylight penetration are 2 and 1/2 times the distance between the top of the window and the sill. Fourth, the reflectance of the room surface. And fifth, integration of electrical lighting controls. For example, switching controls, step controls, and other dimming controls. Innovating of daylighting technologies. Innovative daylighting technologies. The number of innovative daylighting technologies are available which are capable of redirecting incoming sunlight or skylight to the area where it's required. The technology available include sunlight tracking system have the mirror and lenses that follows the sun and redirect its light to required location. Heliostat and light pipe system, mirror system. Daylight system redirect diffuse skylight, skylight and usually sunlight as well. They generally modified as supplement an existing window or roof shelf. Light shelves. This can be used in redirect sunlight and skylight deep in the space into a space. Both interior and exterior light shelves are available. Exterior shelves can also function as shading device. The performance of light shelves depends upon the proportion of shelves which is situated inside and outside the space. This can also be used to control sunlight and reduce glare. Analysis and design tools in daylighting design and analysis. Physical modeling. The physics of illumination are such that light behaves exactly the same way the skilled model does in a full-size room. Physical models can be built inexpensively in various stages of design process. A number of issues can be accomplished within a physical model. Photographs of model interior can be taken and recorded to study various design alternatives. The effect different glass area and location can be studied. Using photometer, illumination level resulting from different daylighting scheme can be complied and used to project the energy savings. Calculation tools. Over these past 50 years, many daylighting calculation tools have been developed. This includes the hand method, monograph, and the computer model to simulate both daylight design and its impact to the overall thermal performance of the building. Following listing describes some available tools. Daylighting monograph description. A hand method that assists designer determine the potential daylighting benefits cost also offers a checking strategies and energy conservation load management. University of Washington graphic daylighting design method description. Determines the daylighting pattern for room based on the proportion of window, worksheet, window openings, providing illumination level and distribution of gradients. AAMA Skylight Handbook Design Guidelines Description. Skylight design analysis will emphasize the optimizing of energy efficiency, incorporating both the worksheet and Lotus spreadsheet. Computer software. Lumen Microsoft description. Lumen Micro description analyze interior lighting designs includes daylight, direct, indirect, mixed, and even aim luminaires. So, Superlit 2.0 description. Update version of Superlit 1.01 now analyze the daylight and electrical lighting for various room geometries. Operation and maintenance of daylighting designs and equipments. Daylighting designs generally employ static elements and do not require significant operation and maintenance beyond the normal building envelope care of area. And last, the application. Among the primary types of building that can be benefits from application of daylighting administrative buildings are daylighting are administrative buildings, educational buildings, storage facilities, and maintenance facilities. And that is the end of my report discussing the daylight design and analysis. Thank you and support us.